Today on The Internet, we have an Elo Touch Systems touch panel display, model ET1939L-8CWA-3-G. Says it right here. And inside, there's a lamp that contains mercury. However, not for very much longer, because we'll be removing those cold cathode fluorescent bulbs from the inside and replacing them with LED strips. On the other side, we have here the touch panel sensitive touch area, which is activated tactily with the touch sensitive appendages we call fingers, just like that. So the first thing is to pull this whole thing apart and get inside. It'll probably be removing the touch panel portion and getting access to the LCD on the inside. So let's start with that. This is a good time for a little bit of fast forwarding and some nice background music. So let's see what's under here. They must have put this little panel on for a good reason. Yeah. That goes out to the touch panel. Alright, cool. We'll carefully remove that. And see if we can pull off the touch panel surface. Here's the actual digitizer. Quite a big digitizer, and it looks to be a capacitive touch. It's not resistive, which is always nice. Carefully put that over to the side, and now we can work on extracting the actual LCD panel, gauging its thickness, and getting that apart. So before I continue, let's just show you how dim this thing is. We're gonna plug in the 12 volts and get a good look at it. Prepare to be dazzled. On. Yeah. Pretty dim. Next part, pull out the screws here and remove the LCD panel. Alright, the screen looks freed up. Let's carefully remove that from inside of the bezel. There we go. Now we have our little CCFL inverter right here on the side. So I'm going to unplug those bolts. And what I want to see is if it will run without the inverter. So that's going to tell us a lot. Luckily, this whole unit does run on 12 volts. So we have a local 12 volts to work with installing the LED strips. That'll be nice. Give me your wires. We'll unplug it here. Yeah. No power for you. Alright, with the inverter disconnected, I'm going to plug in the display again and use my favorite flashlight to see whether or not that panel is active without the backlighting. Oh, light on. that is a negatory on that one. Now I didn't get any activity that I saw on the actual LCD panel using my little hand light after I unplugged the inverter. So I'm going to try using a low-powered green laser pointer to check the panel again. Usually a laser pointer does a much better job because the energy can go through the areas where the LCD panel would normally display white, and you'll get a much better result. So I'm going to turn off the light and we're going to recheck the panel. Turn the panel on and shine near the middle, see if we get anything. Oh yeah, we do. Yeah, we do. Right there. I'll restart it. But you can definitely tell there's something on the display. So now we know the LCD panel is indeed working without the inverter. So the next step is to pull the LCD panel completely out of the bezel, and we'll be looking at how to take that apart and put the LED strips in. Alright, come on, you little LVDS cable. That pin header is a nightmare. Good connectors. Alright, so this is the inverter board. Not much to it. We have a little drive chip here, a couple of MOSFETs. I think these are probably the inductors that are tied to the transformers. Nice little high voltage transformers. Cute little board. Anyway, not important. So let's see what we have here on the actual panel to remove the access to it. That looks like enough. That's good. So here are the LED strips that I'm going to be using. Focus. Yeah. So gotta get a rough idea of how that's gonna fit. Oh yeah. That should be plenty of room. It looks like it just comes apart. I don't see any screws, so there's these metal tabs, and that'll flex out and it'll pop apart all nice and easy and give us access to the inside. Now that I have the metal outer bracket of the LCD panel off, I can carefully remove the actual LCD panel. Now this is where I'm going to have to be very careful because I don't want any dust or debris to get inside of this area here. And I'll start by flipping it over. And I'm going to be undoing the screws that are holding down that board. That's the one with all the little chips and the flex cables. So that's kind of a sensitive area. Usually it says don't touch on there, but hey, you know. And carefully we'll remove the LCD panel. So being very careful with this flex section and these little flex pieces on the side. Here is also where we avoid all the fingerprints. Very carefully. And it should just drop out like this. Oh, that's an interesting color. Didn't expect that. Alright, well, here's the problem. Look how freaking yellow that is. Woof. Right. Well, that explains why it was so dim. We're probably going to replace that with a much better piece of material, because I do have that. And, ew. What an ugly color. Alright, I'm going to remove all those layers. There's a little clips on the side. That's done. On the upside, the other layers look just fine. So it looks like just that one layer may need replacing. And the other layers are going to be the refracting films and other diffusers. Yes. See what we got here. Nope. Just diffusers. So we can actually see how this looks. Just all in all, without this, might look pretty good. Alright, in any case, we're going to have to remove those. So, once again, trying to keep these as clean as possible. Oh, it's taped. I hate when they tape them. On the inside we have this really thick piece of acrylic, and it has some special dots on it for evenly distributing the light. Okay, looks like the CCFL bulbs are the things that come out next. Let's see how they look. The high voltage insulator, line, piece of plastic. Alright. Looks like I just have to snake them out, and the bulbs will come straight up and forward. That'll be nice. Lower side. There you go. Come on. Don't tell me that's riveted. No, it can't be. Really? Really? It is. It totally is riveted. Alright, looks like I'm going to have to remove that. Perfect tool for the job here. Maybe not perfect, but it'll do. Alright, let's try to remove those bulbs again. I'm confused. Alright, well, got that thick piece of acrylic out. Oh, there's a screw here. Huh. Hey, what do you know? I bet that changes everything. Yeah, that does. All right. Now I get to put LED strips in here, and yeah, we'll wire up those LED strips to the 12-volt rail and see if we can get the PWM coming off the LCD driver board to control the brightness of the LEDs once they're installed. First thing is to remove these bulbs. Well, the LED strips are just laying there. Oh, that is a match made in heaven right there. Couldn't ask for better. Focus. Focus. There. Yeah, look at that. Perfect. Perfect. Okay, now we have these two rails, and that's where our LED strips are going to go. Keep in mind that this side was the side for power, so yeah, let's run these LED strips. So, see how long of a strip we can get in there? And cut it to size. It'll be, say, right here. So we'll cut it right there. And we'll lay that strip in. Let's start. See where it will end up being. yeah, that looks good. Now, we're going to add wires to these LED strips, and for that, I'm going to actually use these old return wires. I think they'll be just fine. We'll use the black for negative and the white for positive. Here's how the new installation of the LEDs look, and those rails that the cold cathode fluorescent bulbs are in. And I have the two wires soldered on the ends. We can go ahead and test these out with 12 volts and make sure that they operate properly. Yep, they look to be working just fine. So now I'm going to reassemble the backlighting assembly and get the LCD panel put back together. It has drawn blood. Time to carry on, hopefully without injuring myself further in the process. We're going to lay down the diffusing layers and lock this assembly together and see how it looks. Let's see. These look about the same. So yeah, put these on. Now it's time to reattach the actual LCD panel. Now that the LCD panel is fully assembled, we can hook it up to the LCD display driver and wire in the LEDs on my low power supply and get an idea of how this is going to look now that it's been rebuilt. Grab a little piece of plastic out of the way, and then I'm going to clean the LCD panel surface and get it all put back together. I'm going to need that. Now the other thing that I am going to be doing is making a little board that should go between the 12 volt power rail and the LEDs, and it'll have a MOSFET on it, and the MOSFET will be controlled by the PWM signal that is coming out of the display driver board. Alright, first I'm going to connect the LEDs up. You might see a little bit of the light come out. I don't know, not really. That's pretty in there. Okay, cool. I'm going to turn off the light and we're going to take a look at the illumination. See if it's any better. on. Oh, that is so much better. That is noticeably better right away. Absolutely. Okay, cool. Let's make that little interface board and test that idea out. See where that gets us. Now it's time to fully install the LEDs. For that, I made a little LED driver board. It's just 3 parts: a MOSFET, a resistor, and a board to put it on. I'm using 10K to pull down the MOSFET, so that way it's normally off until it gets a pull-up signal from the PWM coming off the LCD driver board. So the first thing I'm going to do is I'm going to install this inside of the frame, and then we'll go about connecting up the things we need to connect up. Now this is an N-channel MOSFET, so it will switch power on the negative side. So the first thing we're going to have to find is a negative input to go into the MOSFET. That will go into the source, which is right here. So I'm going to use the multimeter and see what our negative rail is, which will probably be connected to ground. And I'm going to use the existing wires that went to the inverter. That's going to give us our 12 volts, and that's also going to give us our PWM signal. So first, let's find ground. I want to see if the ground is the same here. Okay, we can use that reference then. Alright, I'm betting it's going to be the black and the green wires here. You know. If at first you don't succeed, skydiving is not for you. Close enough. Alright, green and black. Yep, that's ground, and green is not ground. Is it? Green has to be ground. Maybe not. Anyway, black wire on there is ground, so I'm going to solder that onto MOSFET source. LEDs don't take very much current, so we won't have to worry about using both the negative / ground wires. Please don't fall down. Fine, go ahead. Make me use the wrong tool. See, every time. The negative of the LEDs will be attached to that later on. Now we're going to need to find 12 volt positive. Let's see which one that is. The 12 volts is red. I believe so. Red and yellow. Looks like. Yep, red and yellow it is. Oh, orange and red. Okay. Let's grab the red wire. And actually no. You know what? I'm going to solder right onto the actual power supply board. That 12 volt positive. If I can. coming out. There we go. Alright, so I'm going to solder on the positives coming from the LEDs onto the 12 volt side. Okay, that's soldered onto the positive. Now the last wire we need is going to be one we add on. Oh no, we don't have to add one on. You just grab it from here too. Alright, it's going to be the PDIM. So we need to figure out which wire that is. Enable bright adjust, which is that wire. Oh, which one is it over here? Alright, so the green wire looks to be our PWM wire for the brightness adjust. So I'm going to go ahead, grab that wire. And I'm going to re-verify that and see if it works. Yep. Alright, last wire to go on. Alright, that should be it. Let's see what we get when we fire it up. Where's that back down? Oh, forgot to connect the negative side of the LEDs to the drain of the MOSFET. Getting carried away here. Alright, well, it's all connected. Time to test. Let's see what we get. Alright, lights off. 1, 2, what the heck will it do? Saw it come on for a second. Oh, it's back. Is that inverted? Is it an inverted signal? No, that's not even fair. It is an inverted signal. Oh, that's fun. Well, it looks like a transistor totem. It will be. So here's a pad that is tied to the fuse that is tied to the source, to the N-channel MOSFET, and the N-channel MOSFET will be tied to the LEDs. Here is a P-channel MOSFET which is tied to the 5-volt rail coming from the LCD driver board, which will be modulated by the negative positive signal. So when it goes positive, it'll turn off. When it goes negative, it'll turn on. Fight against this little 22 kilo ohm resistor, which will send a positive signal to the gate of the N-channel MOSFET, which will turn it on. Yeah, all in the house that Jack built. So let's try this, see if it works. Alright, power for the P-channel MOSFET. To the negative side. To the P-channel gate. And then the negative to the LEDs. Oh, yes. Made this work correctly. See if it does. Yep, that's connected to the connection to the connection. Yep. All right. Off. On. And it works perfectly. On. Look at that. Alright, perfect. At this point, the touch panel display is put back together, so I'm going to go ahead and give it a couple of tests. Really can't see much on the screen due to my obsessively bright shop light, so I'm going to go ahead and turn that off. Much better. Alright, now let's see if the brightness works. Buttons, 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 buttons. That's not the right button. Alright, let's try this. Huh. Brightness doesn't seem to do very much at all. Yeah, very little bit on the low end, but otherwise it's 100% it looks like. Huh, strange. Well, it is a driver signal for a cold cathode fluorescent inverter and not for LEDs, so it might behave a little differently than expected. Anyway, let's go ahead and test out the touch panel function. Now that seems to work. Now, the story on these is there are 3 of them at the shop that I work on. So, we're kind of trying to figure out how to make these better. Did that go away on its own? I don't think it goes away on its own. There we go. So, we're just trying to figure out how to make these work better than they're currently working. Now, the upside is I also know the person uses NVIDIA products. So, the NVIDIA control panel should theoretically give us the ability to control the brightness at the software level. So let's go ahead and try that. Alright, display settings, set multiple monitors. Alright, here we go. Oh, let's see, choose color set, brightness blue. I think we need to flip that to all channels. Flip it to all channels. Nope, I'm using the mouse. Okay, oh, we have to select that, don't we? Alright, here we go. All channels. Let's see if this works. Kind of works. Me and the shopmate will just have to talk about ideas and see if we can get these to run exactly how we want them. I'd definitely say maybe consider getting some brighter LEDs, but that's where I'm at with this video. So, I think I'm going to wrap it up here. I hope you enjoyed, and as always, stay tuned for more.